Are you afraid of the chain rule? Does it seem complicated, intimidating, or even scary? Well, today I'm going to teach you a method for learning the chain rule that is so simple, even your dog can do it. And to prove that this is possible, I've got my dog here today, Zoe. Now, before we get started, we need to lay some ground rules. Number 1, start with the right breed. Chihuahuas, pugs, and poodles may not be ready for this kind of advanced math. And cats are completely incapable of learning the chain rule. They hate it. So start with the right breed. Zoe is a Weimaraner, so she's pretty smart. Number 2, you'll have to start by explaining that the chain rule and leash laws are not the same thing. Otherwise, your dog will think she's going on a walk and she'll just be distracted for the entire lesson and you won't be able to get anything done. When I first told Zoe that we were going to work on the chain rule, she was obviously confused. She thought we were going to take the chain that takes her on a walk, and it took her hours for her to settle down, get ready, and do some math. So, after laying those ground rules, let's get started. Now, the chain rule is used to take the derivative of a composite function. All you're doing is taking the derivative of the outside function, then recopying the inside function, and then taking the derivative of what you recopied. That's all you're doing. Got that, Zoe? The chain rule is also known as the outside-inside rule. Now you have your composite function, f of g of x. You're going to take the derivative of the outside, f, recopy the inside, g of x, and then take the derivative of g of x. And here's your answer, f prime times g of x times g prime of x. Now let's do a couple example problems so that we can really cement this into our brains. Make sure you're paying close attention, Zoe. Alright, we have our first example problem, cosine of x cubed. We have our outside function, which is cosine, and our inside function, which is x cubed. So we take the derivative of the outside, negative sine, recopy the inside, x cubed, and then take the derivative of what we recopied, which is 3x squared. Then we have our answer, negative 3x squared sine of x cubed. See? Easy. Did you get all that, Zoe? Alright, example 2. X squared minus 2x plus 7 cubed. So we're going to bring that exponent down, and it's going to go in front, and then we're going to subtract from that exponent and recopy the function inside of that, which is x squared minus 2x plus 7. Then we're going to take the derivative of what we recopied, which is 2x minus 2. After that, you can just simplify and you'll get your answer. 6 times x squared minus 2x plus 7 squared times x minus 1. Now let's see what Zoe's learned. Are you ready to try an example problem on your own, Zoe? I'm going to give Zoe a really hard example problem. It's actually going to have a chain rule inside of a chain rule, actually inside of another chain rule. So we'll see how Zoe does. Okay, so the first thing Zoe did was she changed that radical into an exponent. That'll make it a lot easier for her. This answer is really long, but she definitely looks like she's getting it. Good job, Zoe. You got it. Now let's just recap what she did, because that was a really hard example. As you can see, this problem has a lot of steps. Tan is the immediate outside function. The derivative of that is secant squared. Then you recopy the inside, and then you take the derivative of that. But to do that, you have to do another chain rule. So then sine is your next outside function. The derivative of that is cosine. You recopy the inside and take the derivative of that. But that's another chain rule. 1/2 becomes your next outside function. Then you subtract the exponent and you recopy it, and you get x squared plus 8x to the negative 1/2. That's your inside. You take the derivative of that, which is 2x plus 8, and then you should get your answer once you combine it all together. Here's the answer again. So there you have it, the chain rule. It's so simple, even Zoe can do it. Remember, the chain rule is used to take the derivative of a composite function. It's also known as the outside-inside rule. All you're doing is taking the derivative of the outside, then recopying the inside, then taking the derivative of what you recopied. It's so simple.